Good evening, everyone. This is Shane Gebauer. I'm the General Manager of BrushyMtnBeeFarm. I'd like to thank you all for being here this evening. And I'd especially like to thank Jim and Maryann Frazier. They will be giving the presentation this evening. They're up there in the great state of Pennsylvania, fortunately out of harm's way for the time being of all the rain that's happening up there. But I do want to thank them for coming in here this evening. Jim is a professor of entomology at Penn State. Maryann Frazier is the I'm gonna botch this, the Honeybee Research Extension Specialist. Is that the official title, Maryann?
Close enough.
Close enough. Okay, thank you for your graciousness. And they're going to be talking this evening about the risky business of pesticides and pollinators. And this is something that I think is very important for beekeepers, because whether we use pesticides in our colonies or not, the bees certainly are being exposed to them in the surrounding environment. So I think their content has relevance regardless of our practices as beekeepers. And I don't want to take up too much of their time because they've got a lot of great content, so I'm going to turn it over to them. And Maryann and Jim, the floor is yours.
Okay, thank you, Shane. Well, good evening, everyone. We're very pleased to have an opportunity to share some of our experiences with pesticides and honeybees over the last several years with you this evening. And we hope that in this presentation it will perhaps change your view of how you think about your colonies and the way they interact with the world at large. We're going to give you some specific examples of our own research on the extent of multiple pesticides impacting honeybee colonies. And then we're going to suggest some things that you can do for your own management practices to perhaps mitigate the impact of some of these pesticides. Or if you find a situation where pesticides have had an undue impact on your colonies, we want to encourage you to use the information we're going to present to make an incident report to help the EPA and other regulatory agencies understand the consequences of pesticide use in today's world. Sometimes those consequences are the result of intentional misuse, and sometimes they're the result of unintended consequences that can be the result of things we simply don't understand about the pesticides when they were registered. So as beekeepers, I'm sure you're aware that honeybees encounter pesticides in the environment in multiple ways. We're having trouble making a change here. We don't have to do that every time, yeah. Honeybees are exposed to pesticides through their visitation to crop plants and the pesticides that are used there for controlling pests. They can pick up pesticides by visiting crops that are not part of a control situation and pick up pesticides inadvertently. As beekeepers, we've been forced to use miticides for the control of varroa mites over the last number of years, and these have built up concentrations in the hive, as we'll show you. And then bees, require a source of water, and depending on what's available in a local environment, their water sources may be a source of pesticides as well. Pesticides in general are mostly nonpolar compounds. That means they're lipid soluble, and so they can accumulate in the wax of colonies quite easily. And once they're partitioned into the wax, they can have a period of half-life there that can be 5 years or longer. And so pesticides building up in the wax are something that can accumulate over time and be present for a long period of time. Our work is focused mostly on pollen as the protein source for the colony, and we've looked at pesticide residues in pollen, and we found, to our great surprise, that the variety and concentration of pesticides in pollen was far more than we ever would have suspected before we started this work. We've looked at the foundation wax that's been used by some of the major suppliers in the country, and to our surprise we found residues of these in-hive miticides that have been used for a number of years in foundation that's being provided as well. And so as this pollen gets processed into brood food, there's also the possibility that pesticides will go into the colony that way as well. We started out in 2007 when colony collapse disorder first broke, and we were called into the scene to try to understand whether pesticides might have any role at all in colony collapse disorder. And so we started cooperating with other researchers, taking samples of pollen from migratory operations and other places across the country. And our first data set was based on 887 samples of pollen, wax, and bees, and very few of these lacked detections. What we found were 121 different pesticides and metabolites of all the different major pesticide classes, including insecticides, fungicides, herbicides, acaricides, and one of the synergists that's commonly used with pyrethroid insecticides. At least 14 of these were systemic pesticides. And to our very great surprise, on average, nearly 7 different pesticides were found on average in each pollen sample, with one sample having as many as 31 pesticides. And so we were really surprised to the extent the fact that nearly all samples had pesticides with an average of 7 different pesticides per sample. And what's unusual about this is that these are of all the different major chemical classes of agricultural materials, and the fact that they're occurring together in the major food for the honeybee colony is a real concern. Here's a list of some of the things that we found. Our samples now are well over 1,000 samples that we've looked at, and the number of detected materials simply keeps going up and up as we look further and further. And because these are insecticides, herbicides, fungicides, there is no toxicological literature about what the impact of combinations of these materials might have on honeybees or on any other animal, really. So we early on did an article to try to, in the American Bee Journal, to try to bring into focus the fact that there are multiple sources of chemicals coming in on the pollen to a colony that the bees are bringing back. There are chemicals that we've used for mite control that are impinging on the colony, and that the major ways that these may be impacting colony health has been the subject of our research and research of others ever since that period of time. So we're interested in the interactions of these pesticides because it's not uncommon for 2 or more pesticides to have a greater than additive effect that can actually have synergistic effects. We're worried that pesticides at levels below which they might cause an outright mortality in the insect may interfere with normal development and physiology and behavior of the honeybees in a way that's detrimental to the colony. And then certainly these pesticides can interact with other stressors like varroa mites and diseases and other stressors to have a combined impact on the colony. So that's the area of research is where we're at. Now, in terms of the exposure of your colony to chemicals in the environment, Tom Seeley has done some really pioneering work on the foraging range of honeybee colonies, and 95% of the time, honeybees are foraging in a 6-kilometer radius from their hive. That's a 3.7-mile radius, which encompasses an area of nearly 28,000 acres. So keeping in mind what occurs in those 28,000 acres around your colony is the first sort of changing perspective that we hope you'll take home after this talk this evening. You don't have control over that area, but you should know what's going on in that area if you really want to have a good understanding of what potentially can be happening to your bees. In times of stress, they'll go even further. They'll go up to 6 miles, which is nearly a triple that size area. And the other thing about their foraging is there's only a 2 to 3 day supply of pollen in the colony at any one time, and so it's a highly dynamic aspect. Based on experiments that Seeley has done with sugar sources, a colony will find the highest reward sugar source within an average time of about 2 hours. So that if flowers are coming and going or blooming or releasing nectar in various times of the day, the colony can adjust its foraging across the daytime and find that source regardless of the direction from the colony. They can readjust within a 2-hour period. So the input of nectar and pollen into the colony is a highly dynamic thing from a very large area. And so if you've never thought about a landscape view of where your colonies are located and where your bees might be foraging, we would suggest this is a good time to do that. It's not necessarily the same view that we have from the airplane here, but you know, if you're in an urban landscape, then the variety of sources is going to be very different from an agricultural landscape. Or if you have large forested areas, that will make a difference as well. So thinking about the available foraging area for your bees is the point we want to make here. The second thing about that foraging is that situation in the United States is not necessarily the same as it is in other countries. And just recently, I was at a conference talking with the people in charge of registration of chemicals in the United Kingdom, and they have about 300 registered active ingredients for the pesticides that are currently used in UK agriculture. In France, a recent paper documented about 500 different active ingredients. And in most European countries, that range is between 400 and 500. Whereas in the United States, we have more than 1,200 active ingredients sold as 18,000 pesticide products. So I think that strongly suggests that the chemical landscape that our bees are visiting and seeing is very different from the chemical landscape in Europe or in the United Kingdom. And so it puts a very different perspective on the research results that are done in those countries compared to what may be done in the United States. Okay, I think it's good to just have some background information on what actually is found in that pesticide bottle when someone is making an application. We talk about active ingredients. That is the actual toxicant material. They can be found in a wide variety of concentrations. Anywhere from 1% of the volume up to 75% can be the active ingredient. The rest of the material in there we call formulation ingredients. They can be, in many cases, the vast majority of material that's in the bottle. We know that pesticides have real value in our current agricultural practices to reduce the risk of loss or contamination by pest insects or mites or ticks or spiders, and that they're sold under a trade name or a product name. So the name of the active ingredient is a chemical name, but the name of the product is very different from that as a product name. Well, why do we have different formulations? Well, pesticides are used in many different ways, and one of the most important aspects of a formulation is usually to make the pesticide water soluble, since water is a readily available universal solvent, and it makes spraying or application of the material to foliage or to leaf plants covering an area quite easy. So a lot of the formulation ingredients are to help these non-water soluble materials actually dissolve or be suspended in water so that they can be easily applied. Other components actually enhance the coverage or the sticking or the longevity of these materials. They may have materials that block the ultraviolet radiation of the sun to prevent the breakdown of the chemical so that its residual in the environment is much longer. Also minimizing contamination of the applicator and assisting with cleanup are other ways that the formulation ingredients are used. But what are some of these common pesticide formulations? You can buy pesticides as dusts, as wettable powders, emulsifiable concentrates, straight out solutions. Ultra low volumes are things usually used for aerial application, aerosol spray cans, or controlled release formulations. And these some of these things are commonly abbreviated like WP for wettable powder and so forth. Some of the formulation ingredients that make up these materials are liquid solvents, dust diluents, things that help stick to the surface, surfactants, help water solubility of non-water soluble materials, ultraviolet protectant sticking agents. Penetration agents are one of the things that we've become interested in most recently, especially a very large class, common class of penetrating agents called organosilicones that are found in most systemic pesticides. And finally, synergist materials that are added to make the active ingredients more effective. Here's an example of one of these organosilicone agents that we've done some work with. N-Methylpyrrolidone is the most widely used penetrant in systemic pesticides, and we in laboratory experiments have used 1% solution of NMP in combination with pesticides, and 1% fed to adult bees really does nothing, but if it's fed to larval bees, it has a very different impact. And you can see here on this red line on the bottom, a 1% dose of N-Methylpyrrolidone in the diet for honeybee larvae kills 50% of them within a half a day, and it kills all the bees within a day. If we dilute that 100-fold down to 0.01% N-Methylpyrrolidone, it still kills 50% of the bees, larval bees, in a 4-day period. So this material is much more toxic to larval honeybees than it is to adults, and it's not uncommon to see systemic formulations that can have 50% of the solution as N-Methylpyrrolidone. So what that impact may have on larvae, we have yet to determine. All right, how toxic a pesticide is the first question you really should ask if you're going to be using it or be exposed to it. And the standard way of determining or quantifying toxicity of a pesticide is to measure the dose, the amount of material that's necessary to kill 50% of the test population that it's applied to. This is called the lethal dose 50, or LD50, abbreviated, for the dose that kills half the population. And we use that dose to kill half the population for several reasons. One, it's the most statistically reliable measure that we can make. It's representative of the population as a whole. It's not at the extreme ends. And so it's become an accepted standard for determining pesticide toxicity. But the LD50 value, how much of a dose kills 50% of the population, depends upon the route of exposure to the animal and the time necessary to have action. So if the material is ingested, that's an oral LD50, is very different from something applied to the surface, which is a topical LD50, and those doses can be quite different. Likewise, the action of the pesticide can vary with the kind of animal that's applied to, by the species, by the age of the organism, by the sex, by the time of the day or the season, by the presence of rainfall or sunlight or different kinds of plant surfaces, or the amount of sunlight that's available during a certain period of time. So all of these factors make the LD50 sometimes difficult to determine, but it is an accepted standard that we use as a reference. And the LD50 value for the active ingredients is always listed on the label of a pesticide. So it's one of the things you should look for first. We mentioned that pesticides can interact. Here's a simple example from some work we've done of a sale as an insecticide that's relatively safe for honeybees, and Nova as a fungicide. And we just show simply 3 doses on the bottom, 1, 2, 3, for 3 different doses of a sale or 3 different doses of Nova, which, when they're presented separately and allowed the bees to ingest it, there's no mortality whatsoever. But if we make a mixture of these 2 materials using half of the quantity that was used earlier, so half the amount of a sale at 3 different concentrations, half the amount of Nova, mix them together and apply them to the insect, you see that we get up to 80% mortality as a result of this highest mixture. So this is an example of synergistic action between these 2 materials. When they're present together, they have far more than an additive effect than if they were presented singly. And so the combination of fungicides and insecticides applied on a plant can be an important component of toxicity for the pollen that's picked up. Well, the relative toxicity then of materials is understood by comparing LD50 values. And the important thing here is that the lower the number, the more toxic the material is, because it takes less material to kill 50% of the population. And so the miticide Coumaphos has an LD50 of 4.63 micrograms per 100 milligrams of bee. And so the units of toxicity can vary in different ways of expressing it, but they should always have the same units if you're going to compare them. So flubalinate only requires 0.15 micrograms, which makes it 30 times more toxic than Coumaphos. Chlorpyrifos, carbaryl, metacloprid only requires 0.028 micrograms per bee, and so that's 130 times more toxic than Coumaphos. whereas the fungicide myclobutanol requires 18 micrograms to kill half the population, so it's only 1/5 as toxic as coumaphos. So keeping in mind that LD50 value is an important component. Pesticides work very different ways to kill insects. The mode of action is the way in which the chemical works, and it works on a given molecular target site, we call it, within the insect or the human. Human nervous systems share many of the same attributes as insect nervous systems, and traditionally many insecticides have been developed as poisons or toxins of the nervous system. There are 23 different recognized modes of action by the Insecticide Resistance Action Committee, and there are differences in the sensitivity. So the same molecular target site within one insect or another, or within an insect versus a bird versus a human, the differences in sensitivity of that molecular target site for the same pesticide can result in different LD50 values. And so this can be a safety factor that can either favor humans being less susceptible to the material than insects, or vice versa. Insects can be less susceptible than humans. And so another important component of poisoning by insecticides for insects is that we may understand the molecular target site in which this chemical acts, that is a given receptor or a given ion channel or a given detoxification enzyme, but we don't actually know which components of the nervous system result in the death of the insect. So we don't actually know the exact cause of death for an insect in poisoning from insecticides. As long as our goal is to kill the insect, that hasn't been really of concern. But now when we enter the realm of wanting to understand the sublethal impacts of pesticides, that becomes far more important. So the fact that the toxicity mode of action may not be the same for sublethal impacts is a really important component, and we'll talk a little bit more about that. Here's an example of a brochure from the Pesticide Resistance Action Committee that shows different modes of action. And you see along the left-hand side that many of the modes of action are nerve and muscle poisons that interfere with certain targets in the nervous system. The fourth one down there, a nicotinic acetylcholine receptor, is the target site for neonicotinoid insecticides. That happens to be a receptor for acetylcholine that is a specific subset of acetylcholine receptors, which is the most common neurotransmitter in the nervous system. And yet we don't know the distribution of those kinds of neurons within the nervous system of the insect. We know they may be in the brain, but we don't know what parts of the brain. They may be in the ventral nerve cord. They may be in ganglia that process certain kinds of information. And so if you have less than a toxic dose and it's going to interfere with some of those nicotinic acetylcholine receptors, the point is we don't know which ones. And so when we're talking about a sublethal impact, if that happens to be acting on neurons in the brain that produce neurohormones, then the hormone coordination system of the insect could be disrupted, and that can have many consequences, from altering pheromone production, altering behavior of many kinds, altering development. So not knowing those target sites for low doses makes understanding the consequences of low doses particularly difficult. Well, pesticide safety is assessed relatively thoroughly during the registration process by EPA using surrogate animals. And so to develop pesticides that are safe for humans, rats are used as a surrogate mammal. Birds are used as representatives of other birds in the environment. Aquatic invertebrates are used as measures of safety to water systems, and the fact that small invertebrates are the basis of the food system there. And then honeybees are used as a surrogate for all other insects. So the testing for toxicity is quite thorough on vertebrate systems. Dose response data is developed for skin irritation, for eye irritation, for whether it causes cancer or not, whether it has developmental effects, whether it has reproductive effects. So that data package is developed by the chemical company that wants to register a compound with EPA, and then EPA evaluates that data. So acute contact toxicity, which we've talked about as the LD50, is the main material that's done first, and if that is low enough, then it forces other kinds of tiered testing to be done, one of which is chronic feeding. So feeding the same material over a long period of time, a much smaller amount can have impacts versus a short one-time effect for acute contact toxicity. And then how the chemical behaves in the environment is assessed through dissipation in air, in soil, in water, and on different kinds of plants, in full sunlight and less than full sunlight, and water of different pH, of soil of different chemical makeup, and so forth. And so this LD50 value on the label and some of these environmental impacts are important components of understanding how long the chemical can reside once you've applied it. There are, however, many limitations on the EPA's current system for evaluating safety of pesticides to honeybees and other pollinators. One of these is that only the acute contact toxicity for adult bees is the only value that's used. There's no testing on honeybee larvae whatsoever. The toxicity is categorized on the basis of how much material is necessary to kill bees into low, moderate, or highly toxic materials. So materials that are highly toxic would take the least amount of material to be toxic to honeybees. And the strongest limitation in the use of that material is a warning on the label. It cannot be refused registration for being highly toxic to pollinating insects or to honeybees. Of course, we'd like to know what the impact of this pesticide has on the colony as a whole, but there is no standard way of testing pesticides on colonies. EPA still does not have a colony protocol available, so the registrants are asked to design and conduct experiments on their own on honeybee colonies, and that data is then reviewed by the EPA. There is no testing of pesticides on native bee species, only honeybees, or other beneficial insects. And so there's a large possibility that pesticides are having impacts on other species that have never been measured before. And the other component about this is that EPA does permit conditional registration for materials for which the complete data package is lacking. You'd think that would be a relatively rare event, but in fact it's not. More than 60% of all pesticides registered lately are given conditional registration with no timetable for when the rest of that information has to be supplied, and it's not uncommon for that to take 5 or as much as 10 years later before that information is actually generated. Now here's the actual environmental hazard warning that would be on the label of a highly toxic pesticide. This pesticide is extremely toxic to fish and aquatic organisms and toxic to wildlife. For terrestrial uses, do not apply directly to water or to areas where surface water is present or to intertidal areas below the mean high water mark. Do not apply when weather conditions favor drift from treated areas. Drift and runoff from treated areas may be hazardous to aquatic organisms in neighboring areas. Do not contaminate water when disposing of equipment, wash water. And then the one statement for bees: this product is highly toxic to bees exposed to direct treatment or residues on blooming crops or weeds. Do not apply this product or allow it to drift to blooming crops or weeds if bees are visiting the treatment area. So one of the interpretations of this label has been, well, it's better to spray late in the day or at night when the bees are not there. So if you apply a highly toxic material to a crop plant or to flowers that are blooming at night, the next day the bees become active and visit that blooming plant. They're going to get the full dose of that pesticide. So even though you're meeting the requirements of the label, it's really not protecting pollinators. While pesticides may be classified as restricted use, this is usually the more toxic materials or special formulations and require a commercial applicator's license to apply these, or a pesticide use license. So they're no longer available for general use. Unrestricted pesticides are materials that tend to be less toxic, the sort of thing you can buy at the neighborhood Lowe's or Walmart store for homeowner use. And certainly these materials are used with less training and perhaps less understanding than what the commercial operators are doing. And so both of these are potential sources of concern for beekeepers. Well, how does the EPA know if pesticides are performing the way they were intended to perform in the natural environment? And that is only through incident reports. That is, unintended consequences that result in bee kills. And these are required by law to be reported to the state agency and to EPA. But the process by which this is to be done is not widely used, and it's something that we want to try to give you some indication of making it easier for you to do that. Like I said earlier, this may result from misuse of the pesticide intentionally or unintentionally, or because sublethal impacts in the way they're measured has not been a part of the registration process. It's not surprising that there can be sublethal impacts that have not been measured, but are likely happening in the real world at this point in time. Once the registrants know that something has resulted in the death of honeybees or other animals or insects in an unintended way, then they're required by law to report that incident to the EPA. And each 10 years of registration, the material is reviewed and new information is taken in. There's an opportunity for public comment. And so there's a reevaluation period that's meant to keep current registrations up to date. And so learning how to do incident reports is one of the reasons why we're trying to give this workshop this evening. So that's a brief background of pesticides, where they come from, how they work, and how they might potentially be impacting colonies. And so I'm going to turn it over to Maryann, who's now going to talk about things that you can do if things go wrong, or things that you can do to help things from going wrong. Maryann?
Okay, thanks, Jim. Good evening, everybody. Thanks for hanging in there with us. I know that a lot of this is very technical information, but we feel it's really important for beekeepers to have a good grounding and understanding of this kind of information to be able to not only understand what's going on, but to be able to speak knowledgeably about pesticides and the potential impacts that they're having on honeybees. So a pesticide kill in the past, and even today, when we see pesticides impacting honeybees, we might see something like this picture, which is a pesticide kill. Lots of dead bees in front of the beehive, basically occurring in a very short period of time, overnight, for instance, or within a couple of hours on a certain day. You might see bees spinning on their backs, bees regurgitating nectar, bees with their mouth parts extended. So this is a typical toxic pesticide kill from again a toxic exposure, most likely due to a pesticide. So we see this and we understand it, and we can, it's a diagnosable situation. Unfortunately, as Jim mentioned, a lot of pesticides today we think are acting at the sublethal level, and so we are having, we feel, impacts from pesticides that we don't necessarily see, or at least not see this kind of characteristic associated with the pesticide impact. But nevertheless, one of the things that we think is very important is to capture this. As Jim said, EPA is making decisions on whether or not there are issues with pesticides based on incident reporting. And for a number of reasons, there are very few incidents of bee kills in their databases. Partly this is because beekeepers who have their bees on crops have a relationship with a grower, and that's a good relationship, and sometimes things happen, and the beekeeper takes the losses, or the grower reimburses the beekeeper for the losses, and it doesn't go any further. Well, that's great for the relationship between the beekeeper and the grower, but unfortunately that information now is not captured by EPA, and whether it was an intentional or unintentional situation, there, according to EPA's database, there's no incident, there's no problem, and so that creates a problem because we are lacking information, we're lacking data. So the National Pesticide Information Center, NPIC, we're going to show you at the end of this presentation that website where you can actually go and make an incident report. and we're really trying to encourage beekeepers to, if there's any evidence of a pesticide incident, to make a report. And there are 3 things that are really required in order to do this effectively. First is to report the incident to your state environmental agency. In our case, in Pennsylvania, PDA, Pennsylvania Department of Agriculture, has a pesticide program, and we would call them. And in some cases, they may actually send somebody out to do some sampling. At the very least, they would take the information down and have it, so you have the state notified. Next, call the National Pesticide Information Center, and the number there is to be able to do that and report the incident. They then hopefully instruct you to go to the Ecological Pesticide Incident Reporting portal, which again we'll show you here at the end of after we finish the PowerPoint. And that's where you'll actually physically make an online report of the incident. I think they're trying to screen a little bit the incidents that are reported, just to make sure that they're realistic incidents. And so they do ask you to call and then make the online report. Lastly, to report the incident to the product manufacturer, whoever the manufacturer is of the pesticide. So this is what this portal looks like. This is where you would actually go to submit a report. But again, they're asking that you make the phone call. It's a toll-free number to say that you want to make a report, and then they'll approve your entry into the portal. But that website also, I should mention, in addition, that's just one small piece of that website. There's a lot of very, very useful information on that site, and Jim will review a little bit of that with you here when we go to the site. So in addition to making incident reports, what else can you do to protect the bees? So one part of this is capturing an incident when it does happen and trying to get that data captured and reported and available to EPA to help them make decisions in the future about pesticides. The other is, how do you protect your bees yourself from even having an incident, pesticide incident? One of the most important things that we know is that we have accumulated pesticides in the hives from our considerable use of coumaphos and fluvalinate for the use of varroa mite control. Varroa mites are a very real problem. They continue to be a real problem, and we have to do something to deal with varroa. And so what are the alternatives? Thankfully, we do have some alternatives now. There is resistant stock, the Russian stock, the reduced varroa hygienic stock, the hygienic behavior stock that is available, and the mite suppression stock as well. SMRs, suppressed mite reproduction, I guess is the acronym there. It's just escaped me. Also using soft chemicals like formic acid, Apagard, Apalivar are materials that can be used for the treatment of varroa. We have some new materials now. HopGuard, for instance, is a new material that can be used to control varroa mites. Reducing pesticide buildup and pathogens by getting rid of old comb and replacing it with new comb. With new foundation, and then essentially the bees building new fresh comb. Jim did mention that we see foundation that's contaminated with pesticides, so there is widespread contamination of foundation. If you yourself have not used a lot of pesticides, your cappings wax is clean, you can buy plastic foundation and coat that foundation with your own cappings. So there are some things that you can do to reduce the pesticide buildup from foundation and so forth. Based on widespread resistance, again, to fluvalinate and coumaphos, really we recommend that that's not be used for control of mites, because it does build up in the wax, and because there is widespread resistance to the materials and they're not really very effective anyway. you may have heard the quote that dose makes the poison, and that's true, that it's all about the amount of pesticide that the bees are exposed to as to whether how poisonous determines how poisonous it is to the bees. So trying to dilute the effects of pesticides are a good idea. So allowing colonies to recover after a pollination of a particular crop where they've been exposed to pesticides is a good idea. Continuous feeding of protein is a good idea for bees that are on crops where pesticides are being used. There is effort now being made to encourage growers of bee-pollinated crops to grow buffer zones, areas like refugia where the bees can go to get away from pesticides, and growers are even being incentivized to do this by being paid to establish these borders. Also, homeowners, we don't necessarily think of homeowners as being large contributors to the pesticide issue, but in fact homeowners are very significant users of pesticide. And if you go to any Lowe's or Home Depot in the early spring, it's very easy to recognize this based on the amount of pesticides that are on the shelves, particularly for lawn care. Homeowners are really being encouraged to reduce their pesticide use and to plant for pollinators. All that lawn with no clover and no dandelions is not useful to honeybees. And so in Pennsylvania we have a Master Gardener program that is actually certifying gardens as pollinator friendly. And they have a series of steps that the homeowner has to go through to get a certified garden, and then they get a beautiful sign to put in their garden denoting them as pollinator-friendly gardens. Lastly, no matter what it says on labels, we are really encouraging homeowners, growers, all not to apply pesticides to blooming plants. Not in the evening, any pesticides to blooming plants. It's just a very bad idea, particularly those that are toxic to honeybees. They should never be applied to blooming plants or be allowed to drift onto blooming plants or weeds. Pollination of agricultural crops, growers who are using bees for pollination and renting bees from beekeepers. It's really important to keep the lines of communication open between the grower and the beekeeper and reduce the exposure of the bees to pesticides. Minimizing the use of fungicides. This is one of the things that we've realized in the last couple of years, that growers, for good reason, are using fungicides in the presence of bees because fungicides on their own are not an issue. They're not toxic to honeybees. But as you've seen in the earlier slides, those in combination with insecticides can be synergistic and be much more toxic. The combination can be much more toxic than the additive effect of the insecticide and the fungicide. Again, never spraying insecticides to blooming plants and or crops and or weeds. And we're really trying to work to get notification of pesticide application to crops, and even to, for instance, here in Pennsylvania, there's application of pesticides for West Nile, for mosquito control, for tick control by the counties and by the state, and we're trying to work hard with them to get notification to those beekeepers within at least 48 hours of application. We have had a pesticide cost-sharing program, and we feel like this is a very important part of the incident reporting, that if beekeepers have additional data, that data in the form of a pesticide analysis that identifies pesticides that may have killed those bees, that makes the incident report much stronger. Because of course beekeepers aren't always going to know if they have a kill what the pesticide was. And in the typical incident reporting, they ask you a lot of questions about the particular material, which in many cases, again, you're not going to necessarily know. But if you have a pesticide analysis to go along with that, then it might be pretty clear what pesticide was involved. This program has been funded by the Project Apis mellifera and the Foundation for the Preservation of Honeybees, and it allowed us to pay for half of the sample, and the beekeeper paid for half of the sample. This pesticide analysis is not cheap, $284 per sample, so this was considerable cost savings for the beekeeper. We're currently out of money on that program, but we hope to get some additional funding to continue that program. The results are confidential, and the nice thing is they get added to our very large database, which is giving us a pretty good picture of what is going on. I mean, a lot of the data that you've seen Jim present in terms of our understanding of bee exposure to pesticides has come from that database. This is what the results look like. They give you, the USDA will give you an actual list of all the pesticides that have been screened for, and then the amounts that have been, the particular pesticide and the amount found in your sample. Also, we then give you the results of the pesticides that are found in your sample, along with the average and range that are in the database overall, so you can compare your results to what's in the database. We want to gratefully acknowledge our funders for this work, which have been significant. The National Honey Board really jumped on this CCD thing right at the very beginning, and we got considerable funding to do the work, particularly around CCD. USDA Haagen-Dazs has been a big contributor to our work. Wyman's blueberry growers in Maine, very significant contributor, and of course some of the others that I've already mentioned. I just want to mention that again, you can find, we try to keep our information about our work up on the Center for Pollinator Research, the CPR, and on the MERIC website, the Mid-Atlantic Apiculture and Research Consortium site. So you can find additional information in those two places. So what we'd like to do now is quickly go to the this is the National Pesticide Information website, and Jim's going to take you through to a couple of places within the site to show you the valuable information that's on this this site.
Yeah, one of the first things you see, there's a map of the United States here, which if you put your zip code in will bring up your local pesticide information source. So whether it's a Department of Pesticide Regulation or Department of Agriculture in your particular state, that information, contact information, will come right up so that you can know who to call and talk to, so you can get the phone number directly off of here. There's a lot of information on this site in terms of human health, animal health, safe practices, toxicological information, the actual label information for different things. The regulations, which can be different from state to state, are listed here as well. It's all kept current. And then under pests and the environment, report a problem is the place where you would go. And let me just click on that to make an incident report. And so it comes up wanting to report a problem. And so the first thing is to call this number, and they will talk you through this. And so they will get some information on the phone for the very beginning. And then if this is a verified incident they want to have captured, then you can go down here under reporting an environmental incident. And we've talked to the people about including honeybees on here as other kinds of wildlife. And so reporting that incident is exactly what they will have you do. And this is the one thing we showed early on about the 3 steps to go. So this is a very good website. It's funded partially by EPA. These people make annual reports to EPA, so we think this is the best route for informing EPA of the consequences of pesticide use on pollinator health. So I think we'll just stop there and ask if there are any questions or any points of clarification we can offer in terms of what we've tried to cover.
Well, thank you, Jim and Maryann. There are a couple of questions that have come in. I also have a few myself. While we've got this site up in front of us, you mentioned there's some toxicology information there. Is this something we get here at the business? We get a lot of people calling in saying, you know, my neighbor is applying this. Is this something I should be concerned about with my my honeybees? And of course, as you noted, there's 1,200 active ingredients out there, and I am by no means a pesticide expert, and so I just say, well, refer to the label. Is this a site that I could refer someone to say,
yes,
okay,
absolutely.
so they've got this information here, and they can sort of go through and see exactly what would be on that label, and also, does it have information that maybe the manufacturer has submitted to the EPA as part of their application for registration?
Yes, that information is there as well. And so one of the confusing things is that if you don't know the name of the active ingredient, you may have the name of the product. And so the label name is usually very different from the active ingredient. You can get to that source of information with either one of those names. So if you know that they've applied a spray material by such and such a name, you can look that up on here as well, and it will tell you what the active ingredient is. It will tell you how safe or how toxic it is for honeybees and how long it's going to last and so forth. Also, if there's been a misapplication and someone has been poisoned, there's emergency information on this site as well. So this is a really good place to go.
Great. Can we revisit LD50? There was one graph that you showed with the N-Methylpyrrolidone, I believe it was.
That's correct.
That showed different time frames based on dosage. So what time frame does the EPA look at to assess an LD50? Is it, you know, basically I expose a bee to a certain percentage or a certain concentration within a day, within 2 days? Yeah. What time frame is used to determine the LD50?
When I say an acute contact LD50, that means a short-term measure, and so it's applied to the outside surface of the insect, and the mortality at 24 or 48 hours is measured.
Okay, so it's basically within a day or two to determine that LD50.
That's correct.
Okay.
That's the first measure that's taken, and then if that is highly toxic, then you might want to look at it for a longer period of time. And this particular graph that I showed of N-Methylpyrrolidone is different for larvae because we're actually rearing honeybee larvae in the laboratory in artificial conditions in vitro, and we're following the larval development all the way through from egg to pupation. Mm-hmm. So these days of larval development are what's indicated here. So that's different than a standard dose response.
Right. And now, did I understand correctly that this is not actually an active ingredient, that this is part of the inactive ingredients?
That's correct.
So
inactive, but it's not really inactive biologically from the standpoint of bee larvae.
Right. So is there any movement to get manufacturers not only to assess the active ingredients, but also the inactive ingredients?
We would hope, because that measurement of the inactive ingredients is actually part of the registration process in Europe, although it's not currently part of the registration process in the United States. There was a conference earlier this year that I participated in with scientists from all over the world looking at trying to merge and have complementarity between the registration processes in Europe, in Canada, in the United States, and elsewhere. And there's a lot of positive movement in that direction, which I think will be a great step forward for having greater pollinator safety in our registration process than we currently have.
It seems like the potential for synergistic effects here with when you're finding so many, and in fact the average sample in the pollen of 6.7 different pesticides, the potential for synergy between those various pesticides is tremendous. How much work has been done to look at that? I know with so many different pesticides, there's almost an infinite number of possible combinations, but have you looked at some of the more frequently occurring pesticides to see how they may be interacting to affect toxicity?
Yeah, that's a very good question, and we have taken that task on. we run a fairly large number of laboratory studies where we looked at combinations of the 5 most frequently occurring pesticides found in pollen, and we've done that both for adult honeybees and for larvae. And we have seen synergism in certain mixtures, but we've also seen the opposite, which is called antagonism. And it's fairly common in mixtures of 4 or 5 chemicals together that the toxicity of that 5-component mixture is less than you would predict from the additive toxicity of the individual components. So sometimes at the metabolic level, the presence of one chemical can interfere with the action of another, and we see that fairly often in the results that we've gotten so far. So it's not predictable. There are certain chemical classes of fungicides we know will synergize certain chemical classes of insecticides, but when we start adding fungicides and herbicides into the mixture, it's completely unknown. So we're going about that, but we're certainly not going to be exhaustive with our resources to be able to test all those combinations.
There's a couple questions along the same line here that regarding identifying whether you've been your colony's been a victim of pesticide poisoning. Are there any other indicators? Because frankly, you know, I saw that cost sharing thing, and while that's fantastic that the beekeeper doesn't have to come up with a full $284 or whatever it was, that they only have to come up with half, but that's still a chunk of change for some folks. So are there other things that we can look for as beekeepers to say, yes, this is clearly or at least a good chance that this is pesticide poisoning, and I really want to be diligent and follow up on this and submit that incident report, but I don't want to, you know, shell out the cash without being fairly certain on my own account first. So what sort of indicators, Maryann, besides just a lot of dead bees out in front of the colony, could we use to say this is a result of pesticides?
Yeah, I mean, there's a lot of reasons why colonies might not be. And so of course, there's the outright toxic effect when you see the dead bees in front of the hive, which is pretty straightforward. And then, you know, there are lots of other reasons why colonies might not look very healthy, why there might be issues around them. Varroa mites, for instance, is a huge one. You know, other diseases, like this is now when we start to see what look like viruses, like this you know, deflated brood in hives and so forth. Of course, our typical diseases like foul brood and that kind of thing. I mean, you want to kind of get a sense that none of these other things are, you know, if there's something wrong with a hive, it's not performing well, it's not building up, it's not doing what it's supposed to be doing. What I would suggest is that you try to eliminate some of these other things that might be responsible. Make sure that the varroa mite levels aren't out of control, that the you know, nosema levels aren't out of control, that there aren't other signs of things like chalk brood, for instance. Of course, we have things like skunks and raccoons that can create a loss of bees as well, that can cause a population in a hive to go down. So, but there's evidence of that, you know, scratching in front of the hives and the dirt torn away in front of the hives, that kind of thing. So I think with pesticide, you know, you're trying to decide whether or not there are pesticides involved. I think to try to eliminate some of these other things that might be causes for a decline in a healthy bee colony is probably a good thing to do. And if there is, you know, the other thing you might do is if a colony is not performing as well as it should, you know, requeen it, for instance, to make sure that there's not an issue around basically a poor queen. But if there are, you know, no real unexplained reasons why a colony is going down or not building up, not producing honey, and you see, for instance, one day the field force is flying strong, and then the next day a perfectly beautiful day, and there's no bees, you know, no field bees coming and going from that colony, and there are no other really good reasons why that colony might be so quickly going downhill. You know, there's probably a pretty good chance that pesticides are potentially involved there, and so those are the kinds of things you might think about and look for, and consider whenever you're sending a sample. The other reason people might want to send samples, I would just mention, is that while we know that honey is pretty safe, the USDA has engaged in a process where they sampled 744 samples of honey across the country to look for pesticides, and because most of these pesticides are not that they are lipophilic, they want to dissolve in wax. Honey was very, very essentially free of pesticides. There was very little pesticide in honey. But think about things like pollen. If you're selling pollen, or if you're selling comb honey, then in that case you may want to have your products tested for pesticides. That's the other reason, in addition to a potential pesticide incident.
How should those samples be submitted? Do they need to contact someone beforehand? How do they go about doing that?
Absolutely. They need to contact me, send me an email, and the reason for that is because we only have a finite amount of funding, and so as I said, now we just ran out of the money that we had for this, and so we don't really have any money for incidents, for cost sharing, excuse me. But if a beekeeper is very anxious to have a sample done, then they're willing to pay the full cost, we can still handle that. So they can email me, I can tell them what the status of the program is, and provide the instructions in an email in terms of how much material we need and how to take the sample and how to send it to us, and additional information along those lines.
Okay. I want to be mindful of your time. We're at the top of the hour here. I just have one more question, because I see this coming up more and more frequently now as we're looking at a lot of different things in honeybees and ways to keep them healthy. The importance of good nutrition. Of course, good nutrition is sort of intuitive on its own, but I'm curious if Jim, you know the mechanism. You mentioned the continuous protein feeding. Or maybe it was you, Maryann, that said that was a good way to sort of help offset the impact of pesticides. What's the mechanism there, other than just overall good health? Is there something that physiologically there, metabolically there, that allows the bee to metabolize those pesticides more efficiently? Do we know what's going on there?
Yeah, that's a very good question. Of course, mechanistically there are a number of things that can be going on, but in general, if the bee is being stressed by one or more diseases in combination with the pesticide, then a normal functioning immune system requires a lot of energy, and detoxification of pesticides requires a lot of energy, metabolic energy. And so those two things together can be perhaps more than the bee is able to withstand. And so in times of that kind of stress, having extra protein available is really a good, safe thing to try. And in fact, some of the largest migratory beekeepers are doing that on a very large scale these days just to keep their bees going. So without understanding the full mechanisms involved, we know that's a good thing to undertake.
Well, great. I do know that the two of you are very busy, and I want to thank you for your time. I also want to be mindful of your time, taking you're out of your very busy schedule and joining us here this evening. So I do thank you very much for that. There's been a couple questions here about access to this information after the fact. Like all webinars, this is being recorded and will be posted up to the Brushy Mountain video library, which can be found under the resource tab on our home page. Give me a day or two to get it up there, but it will be accessible and archived there, along with all the other webinars that I've done in the past. Again, Jim and Maryann, I appreciate you taking time out of your very busy schedule, especially under the conditions that you're in up there in Pennsylvania right now with all the rain and flooding going on, and glad to hear you're safe. Thank you again, and I really do appreciate this. This has been some wonderful information to share with beekeepers, and hopefully it can make us a little bit more successful in the future. So thank you very much.
Thank you, Shane. Yeah, thank you for putting this together. We really appreciate the work of Brushy Mountain to help us bring this information to the beekeepers.
Well, it's my pleasure. Thank you, and again, be safe, and thanks again.
Thank you.
Bye-bye.